Scaling dimensions proportionally. Today we're going to be talking about area and how it changes as you change side lengths. So we're gonna go back to some definitions. A ratio is a comparison of two numbers by division. For example, if I have a bunch of dots, I can say that the ratio between the red and the blue dots there is 8 divided by 2, which we would usually simplify to be 4. The ratio is 4 to 1. A scale factor is the ratio of sides between two similar figures. So we could say 15 divided by 5 is 3, or 6 divided by 2 is 3. So the scale factor, which I'll usually write as D, is 3. What this means is that 2 times 3 is 6, and 5 times 3 is 15. Now it's tempting to say, okay, the area is 10, so if I wanted to find the new area, I would take times 3. I would take 10 times 3 to get the new area, but that's not true. 10 times 3 would be 30, but the new area we could do with 15 times 6. That's definitely 90. So it's not true that 10 times 3 is 90. It's 10 times 3 times 3 is 90. 10 times 3 squared, or 10 times 9, is 90. This is because we multiplied by 3 in both directions, so that's why we're getting 3 squared. So the big lesson for this video is that when you're multiplying by a scale factor, the area doesn't change based off the scale factor. It changes based off the scale factor squared. So one-dimensional measurements, such as length, width, height, and perimeter, have a ratio equal to the scale factor. This is like taking the 15 divided by 5 to get that the scale factor was 3. But two-dimensional measurements, so the new area was 90, the old area was 10, have a ratio equal to the square of the scale factor, 3 squared, or 9. So how do we use this? If we have that something's dilated by the scale factor of 7, D is 7, so when we talk about the ratio of the areas, it's going to be D squared, or 49. So the new area will be 49 times the old area. The old area was A, so 49A is the new area. Here, we have a triangle is dilated, so the new triangle has hypotenuse 15. So this, we can use Pythagorean theorem to say 3 squared plus 4 squared, this will be 5. If you've forgotten Pythagorean theorem, this is how I'm getting the 5. And then from that, we can do 15 divided by 5 tells us the scale factor was once again 3. So we can take the old area and multiply by 3 squared. The old area was 1/2 base times height. So the old area is 1/2, 3 times 4 is 6. So we can take that 6 times 3 squared, 3 squared being here. 6 times 3 squared gives us the new area is 54. A triangle's base is 24. And it's dilated, so the new figure has 16 times the area. So 16 times the area says that the area is being multiplied by 16. So the scale factor is not 16. The scale factor squared is 16. So that means that the scale factor was the square root of 16. So I took square root of 16 to get 4, and the scale factor will be 4. So what's the length of the base of the new triangle? I'm going to multiply by 4. 24 times 4 is going to give us 96 is the length of the base of the new triangle. Lastly, many dollhouses are built with a scale factor of 1/6. So every measurement is divided by 6. So what's the ratio of the areas? The ratio of the areas is to take that 1/6 is the scale factor, and then we want to square it to find the ratio of the areas, so that will be 1 squared is 1, 6 squared is 36. So the ratio of the areas is 1/36.